गुड मॉर्निंग स्टूडेंट्स। तो कल का लेक्चर समझ आया था? Okay, so yesterday we did the K-map with using 4 variables and 6 variables, and also we have seen that how the K-map would be designed for the 4 variables and 6 variables. So now the topic for today's lecture is binary codes. So basically, it is used to represent any number in the binary form. Binary means 0 and 1. 0, comma 1. So in the coding, when numbers, letters, or words are represented by a specific group of symbols, it is said that number, letter, or word is being encoded. Now suppose if we have a letter or word ABC and we will write down it like comma, straight bar, and then forward slash bar. That means we are encoding the number ABC into this format. So any number, letter, or word are represented by a specific group of symbols. So that is called the number is being or the data is being encoded. So the group of symbols is called code. So the result of encoding the data into another form is called code. Okay, and the digital data is represented, stored, and transmitted as a group of binary bits. So whenever we talk about the digital data, it is always represented, it always stored, and it is always transmitted in the group of binary bits. That group is called the binary code. So now we will understand that the data when being or the code when written in or the formation that will convert the data into the 0 1 form. That means we are encoding that data into the binary codes. So binary code is represented by the number as well as the alphanumeric letter. So any kind of numbers or alphanumeric letters can be considered under this binary code. So the advantages of binary codes are they are responsible or they are used in many types of cases, like they are suitable for computer applications because as we know that computer will store the data in 0 1 form. They are also used for digital communication because any kind of data transferred from source to destination will be in the 0 1 form. It is stored as well as transmitted in the same form. So binary codes make the analysis and designing of data circuits easy if we use the binary codes. And since 0 and 1 are being used, implementation becomes easy. We need not to yeah, we need not to design the huge number of equations or complex equations to represent the data in digital form. It is just represented in 0 and 1. Clear? So the classification of binary codes will be done in these types or these categories. First is weighted codes, non-weighted codes in which we have accessory code and gray code. Then BCD is there, binary coded decimal is there, and last we have alphanumeric codes. Okay, so this is the classification of or the categorization of binary codes. So let's discuss it one by one. First is weighted codes. So the weighted binary codes are those codes that will obey the positional way principle. Okay. So positional means whenever we move from left to right, the position is increasing. Like this is the first position, second, fourth, 8, 16, 32, 64. From that particular position, we will see how that data will be converted to the binary form. Each position of the number represents a specific weight, right? Whenever we talk about the specific position, this will represent 1, it will represent 2, then 4, then 8, 16, 32, and 64, and so on, up to 2 raised to power infinity. So several systems of the codes are used to express the digital decimal digits 0 and through 9. So various systems are used in codes to express the decimal digits, and in these codes each decimal digit is represented by a group of 4 bits. So each number or each letter is represented in a group of 4 bits, because we have a number from 0 to 9, and from 0 to 9 it will start from 0 0 0 0 to what will be the 9 is 1 0 0 1. All the other numbers will be meant by, like if we talk about 10, it will be 0 0 0 1, and that will become 0 0 0 and 0. So this is the binary form of this 10 number. Okay. So similarly, that decimal 2 and 4, decimal number is 2 and 4. So we will have to convert it like this. This is the positional weights over here and over here. And the representation of 2 is 0 0 1 0 and 4 is 0 1 0 0. So that will be transmitted. Okay. And when that will be transmitted at the received at the other end, suppose the data is gone like 0 0 1 0 and 0 1 0 0. So it will be divided into 4 bits, and then converted to 24. So this is how these weighted codes will work. Clear? So next is non-weighted codes. So in which the position weights are not assigned, but they are used to encode the number into the digital form. So in this we use access3 code and gray code. So let's discuss it one by one. So first is access3 code. It is also called XS3 code. Clear? So it is a non-weighted code used to express the decimal numbers. So XS3 words are derived from the 8421 BCD code words, adding 0011 or 3 to each code word in A48421. So basically that will be implemented over the weighted codes, because they will convert the word into number into 8421, and we will add 0011 into this, and that will be converted to it. So like let's discuss the example. Like we have 24. First of all, we will drive 2, and we have 0 0 1 0. So decimal okay, sorry. So the value of 2 is 0 0 1 0. That is the BCD. We will add plus 3 in it, 0 0 1 1. So it will become 1. Okay. So 1 and 1 is addition is 0, and here it is 1, and it will become 1 0 1. So that will become 0 1 0 1. So that will be converted to 5. If we add 3 in 2, our result is 5. Clear? And when we have 4, so that 4 will be 0, 1, 0, 1. So we will add 3 in it, and the value of 3 is 0, 0, 1, and 1. So it will become 1 and 1 is 0. 1 is gone over here. Sorry, their binary addition is there. 1 and 1 is 1, and then carry is 1. So 1 plus 0 is 1. 1 and 1 is again 1. So we have 1. So 1 plus 1 is 1. Okay. So we have 0, 1, 1, and 1. So that it will become 7. So 57 is the SAS3 code of this 24. Clear? So see, these are the terms of these are the conversions of 0 to 9 decimal number. Then BCD is there, and then their SAS3 code is there. Just look at it for some time, and then we will move further. Okay. Further, next is the gray code. So again, a non-weighted code, and it is not the arithmetic code. That means there are no specific weights assigned to the bit position. And this gray code has a very special feature that only one bit will change each time decimal number is incremented. Okay, as only one bit changes at a time, the gray code is called unit distance code, because every time we will implement the gray code, only one digit will change. It is a cyclic code. The output of the gray code depends upon the XOR gate. XOR gate is in which when the inputs are same, we will get 0. Okay, and when inputs are different, we will get 1 as a result. If we add odd numbers of 1, the output will be 1, and if we get even numbers of 1, the output will be 0. So this is the XOR gate of it. So this is the binary code, gray code of the BCD. Let's discuss it one by one. First is 0, 0, 0. So again it is 0, 0, 0. 1. For 1 we have 1. Okay. For 1 and 0 we have 0, 0, 1, 1. So how it will happen? See, we will implement plus sign from right to left. Okay. So at two positions, no change will be there. Now for 1 and 1, it will become 1 plus 0. We have 1. Okay. Then again, 1 plus 0, we have 1. Then 0 plus 0, we have 0, and fourth is 0 as it is. Next is 1 plus 1 is 0, and 0 is there. Next is 1 plus again 0 is 1. So 0 plus 0 is 0, and that will be as it is. So next is 0. So 0 will come as it is. Then 0 plus 1 is 1. Then 1 plus 0 is 0, 1, and then 0 itself. So let's say the last number 1 plus 0. 1 plus 0 is 1. 0 plus 0 is 0. So 0 plus 1 is 1, and 1 is as it is. Clear? Yes, everyone, clear or not? Okay. Then we have the binary coded decimal. This is just the representation of decimal numbers into BCD. So in this code, each decimal number is represented by a 4-bit binary number, and BCD is just a way to express each of the decimal digit with the binary code. So basically, in 4 digits, we will move from 4444 to 1111. But in BCD, that is the main difference between BCD and actual 4 digits decimal number. That in BCD, we will use only from 0 to 9. First 10 numbers will be used, so we will move from 0000 to 1001, which is the value of 9. Remaining 6 code combination, that is 1001 to 1111, are invalid in this BCD. So this is the representation of decimal numbers from 0 to 9 in this, and just take a look at it. It is 0000 to 1001. Clear? Then alphanumeric codes are there. A binary digit or bit can represent only two symbols because it has only two states, but that is may not enough for communication as we go advanced. So because there are need of more symbols for communication, so alphanumeric codes use 26 alphanumeric symbols with capital letters and small letters and numbers from 0 to 9, then punctuation marks and other symbols. So alphanumeric codes are the codes that represent numbers as and alphabet characters. So next is the complements. First, one's complement. The one's complement of a number is by changing the NOT gate over the bits. So like 1 0 1 0 1 0 1 is 0 1 0 1 0 1. Clear?